Today we were looking at perpendicular lines. I know in previous courses you look at perpendicular lines, but it really at this point has probably been just the basics. So what we're going to do is we need to look at the definition of perpendicular lines, which we're going to do right now, along with other theorems that go with it. So number one, now there's two ways you can talk about perpendicular lines when you're looking at the definition. So in using the diagram below, if line JK is perpendicular to line MN, then each number angle is a right angle, which is also 90 degrees. We could also say the converse. If any one of the numbers' angles is right, or 90 degrees, then we know that the lines are perpendicular. So again, the biggest thing as we explore some theorems is we have to decide when am I going to use definition of perpendicular lines and when do I use a theorem. The biggest thing with definition of perpendicular lines, it's talking about a few things. Obviously, they have to say that the lines are perpendicular, but this right angle or the fact that they're 90 degrees. Same thing in the second version of your perpendicular line definition is I'm talking about the fact that the angles are right or they're 90 degrees and the fact that they're perpendicular. So they're the focus. Perpendicular lines, right angles, or 90 degrees. If you see that, then we're discussing the definition. Looking at the theorems, here are two theorems that they're actually the converse of one another. The first one says if two lines are perpendicular, then they form congruent adjacent angles. And the other theorem says the converse. If two lines form congruent adjacent angles, then the lines are perpendicular. So in looking at our little graph below, let's do some examples. So in number one, it says if two lines are perpendicular. So if I tell you if line AB is perpendicular to line CD, then I can say angle 1 is congruent to angle 2. Okay, again, if the lines are perpendicular, then the angles are congruent. Okay, and the second theorem, again, it's the converse. So instead of starting by saying that the lines are perpendicular, my hypothesis there is that they're congruent. So if angle 1 is congruent to angle 2, then I can say line AB is perpendicular to line CD. Now again, remember in our definition, our focus was on perpendicular lines along with 90 degrees or right angles. These two theorems, the focus is on the fact that if the lines are perpendicular, then they form a congruent adjacent angle. So congruency is really the focus in here on either of them. In our last theorem today, it says if the exterior sides, now remember the word exterior means outside, so the exterior sides of two adjacent angles are perpendicular, then the angles are complementary. So I'll read that again. If the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. So complementary is actually going to be our focus on this one. So if we use the diagram below, for instance, if I say if ray OA is perpendicular to ray OC. Now again, OA and OC, they're the exterior rays, they're on the outside, of two adjacent acute angles are perpendicular. If I tell you they're perpendicular, then I can tell you that angle 1 and angle 2 are complementary angles. So again, obviously perpendicular is going to be part of it, but our focus on this theorem is the word complementary, that when I add the two together, they're going to be complementary. So today's lesson was basically just looking at the definition versus the three theorems involving perpendicular lines and making sure we understand when we use each one. And in further lessons, we'll do some more examples of specific problems.